Hello and welcome back to yet another episode in our Golang crash course. My name is Chris Franklin. Now we're starting to get towards the end of the crash course here. We've only got this and two other episodes really to dive into the last fundamental pieces of the language before you'll have to move on to a more advanced Go course to start digging into some of the bigger, broader details of the language. Now, unfortunately, this is the point at which most people start to get a little bit confused, especially if they're new to programming in general, okay? This lesson, we're going to be diving into arrays and slices, which is basically an array's much more attractive cousin. So, if you come from a previous programming background, you're going to be used to arrays. You're going to know what they are. They're a way for us to store a contiguous addressable space of data. We're storing a whole bunch of different values right next to each other in memory so that we can just walk through one item at a time and see what is being stored within this space. But in Go, they work a little bit differently than you might be used to. So let's dive straight in and start looking here. If you're coming from the world of something like JavaScript or Python or Ruby or any of those languages, you're going to be very used to what are called dynamic arrays. These are arrays where you can store data into them, and when you run out of space, they just get bigger, and you can continue adding stuff to them indefinitely. Okay. However, if you come from the world of something like C or C++, when you create an array, you give it a default size, the size that you want that thing to be. And then if you run out of space, you're out of space. You have to create a brand new array that is bigger than the one that you already created and copy all of your values from the old array into the new array. So it's much harder to work with arrays in the world of C than it is in something like JavaScript and Python. Okay. Go leans more heavily towards the C-style arrays than it does towards the JavaScript-style arrays. However, there is good news for both sides. One, it is easier to work with arrays in Go than it is in C. However, it is harder to work with arrays in Go than it is in JavaScript and Python. So let's go ahead and start looking at what these things actually look like and start viewing how to actually work with these. So let's start with an array. We'll get into slices very soon, but we're going to start with the base data type, and that is arrays. So I'm going to create a string array. And as I said, you have to give it a defined size. So I want to put 2 strings inside of this variable. Okay, so this is the basic way to define an array within Go. I'm going to give it a name, so in this case str, and then here as part of the type I have to put this brackets with a size at the beginning, saying I want an array with 2 items in it and they're going to be of the type string. Okay, and then I can, within the array itself, I can say in slot 0 you start at the first index is 0 and 1 is your second index. You say in slot 0 I want to put a new string, so I'm going to say hey. And then in slot 1, which is the second slot, I'm going to say there. And then here, I'm going to get rid of hello world inside of my print line. And I'm going to print str0 and str1. So if I run this, go run dot, you'll see I get, hey there, 2 strings. So I can now store these strings inside this array and then reference them by their index here and pull them right back out. But what does this thing actually look like if I print it? So let's look. Let's see what's in here. So if I print out str, you'll see that this is the bracket saying that this is an array, and then each slot has a string in it. The first slot is hey, the second slot is there. Okay? Now, I can also do what's preload the array with what I want inside of it. So if I want to do that, I can do the shorthand declaration here, and I can say colon equals, so str2 colon equals, and this time I'm going to create 3 objects in a string array. And then similar to the way that we can work with structs, where we can declare them in line with the brackets. We can do the same thing with an array. So I can do the curly braces here, and I can say loading, and then another string, and then another string array. Now if I print this out, fmt.print line, and I print out str2, I save this and I run it, you'll be able to see that now I have a second array that is preloaded with the 3 values that I shoved into it. Alright, well, that's not very easy to work with, because now if I want to add stuff to the end of this, it gets a little bit complicated, and if I want to only take pieces of this and look into a smaller segment of the array or work with only subsections of it, this starts to get really complicated. I have to start copying things around to new arrays, creating new arrays. So Go provides a little bit of a convenient way to interact with arrays, and they call this slicing. Okay? So let's create a new array, and let's look at how we can look at slices of this array. So I'm going to create a new array, and I'm going to call it evens. And I'm going to put 10 values into it, and I'm going to make them all integers. So we're not going to work with strings. We're going to make this really easy. We're going to work with integers now. And then I'm going to preload it. I'm going to say 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So I'm preloading. Oh, let's make sure we do commas and not dots in between there. I'm preloading the array. When I save this, you're going to see that there are 10 values in here starting from 2 to 20, and it's the even numbers. Okay, so this is great. It's fine, but now this is going to be a little complicated. I only want to go through the first 5 here. Do I count through in a for loop and say stop when my index is greater than 5? I could, but I could also use a convenience function, and that's what I'm going to do here. So I'm going to create SL, which is my selection, and I am going to make this an int slice. The way I declare a slice is I do the same syntax as an array, but I don't put a number inside of it. So I'm saying I'm creating an integer slice. And what this integer slice is going to be is I'm going to take the evens array that I declared above, and I am going to give it a start and end index. So in this case, if I don't pass anything in here, then I will start at 0 and go all the way up to 10. So I will have a slice of the whole array. Or I can do 0 to 5. Okay. Now if I print this out, fmt.println, and I print out the selection, you'll now see that I have grabbed a slice of the array, of the evens array, from 2 to 10. 2, 4, 6, 8, 10. Only this subsection right here, all the way up, and I go 0, 1, 2, 3, 4, and then stop. So this is non-inclusive, the 5 here. So I don't grab this, I just grab the slot before it. Okay? So that's a good way of working with it. Now, here's the fun thing. If I want to interact with this array, if I want to change it and I want to touch it inside of the array itself, and I want to change the values in it, I can actually do that through slicing. This is because a slice is basically like pointer references to a subsection of the array. That's what slicing does. So that's why we learned about pointers. This is a way for me to see a selected view into the underlying array data structure. For instance, I can say a colon equals, and I'm going to take the same slice that I had before, from 0 to 5. Okay. And then I'm going to say b is equal to evens from 1 to 6. Okay. Now when I print these out, I can see A and B are going to be slightly different views into the same underlying array. So I start at 2 and go to 10, and then I start at 4 and go to 12. Okay. I can also take and say b of 0 is equal to another number. Let's say 42. We're going to put b0 equal to 42. Now b0 is 4. All right. So what is this going to do to a? What is this going to do to evens? let's look. fmt.print line, and let's print out evens, A and B. Let's see what happens to these data structures under the hood. So I changed it in B, the B slice. What am I going to see? I'm going to see that the underlying array itself has changed. My second slot has changed to 42. Why? Because B, which starts at the second index, its first slot has changed, which means my second slot in my entire array. And that means A has also changed in its second slot because it starts at index 0 and goes up to 5. All right? So this is great. This gives us a way to easily work with arrays without having to actually use the array. We can use smaller pieces of it by using slices. We can move slices around. We can actually slide slices up and down. We can resize them. There's a lot that we can do with a slice that is very difficult to do with an array. So we can create an array much bigger than we actually need and start with a smaller slice of that array and resize it as we need to change the view into the underlying array. So this is a way that we can create more of a dynamic array that we can work with like we would be used to in other languages. Okay. But let's say we want to grab the whole array. How can we do this? So we can say A1, let's say colon equals evens, and we can give it default bounds. Oh, we want square brackets. And if I do a semicolon or a colon in the middle here with nothing, that means I want to grab from start to finish of the entire evens array. I can also say that I want to only see I want to see everything from the start up to 5. So I want 0 to be my default. So I can do this, okay? Oh, cancel. It looks like I accidentally started the debugger. Sorry about that. All right. So if I go back to my terminal here. All right. Let's now let's actually print this out. Let's do let's do format dot print line, and we're going to print out A1 and B1 and see what they look like. Okay, so if I print these out, now you'll see that these two down here, I have grabbed the entire array, and then I've grabbed the small first, the same slice that I grabbed above by declaring 0 to 5. Okay, so we have default values that get passed in here. The default of the beginning is 0. The default of the end is the last item in the array, the underlying array. Okay, so those are the default bounds. Now, how do we know how big the array that we're working with is? There are two things that we can interact with. So we're going to use B1 to look at this here. I'm going to say format.print line, and what I'm going to look at is the length of B1. All right, what do we think the length of B1 is going to be? It's 5. The length of B1 is 5 because there are 5 values inside of this slice. All right, but what if I take format.print line and print out the cap, the capacity of B1? What do you think this value is going to be? I'll give you a hint. It's not 5. If I run this, it's 10. Why is it 10? Because the underlying array underneath B1 it's the size of this entire array. There are 10 slots in the underlying evens array, which this is a slice into. So we can see the capacity is different than the length in this case. All right. So this is great. This gives us a really nice way of looking into the data. But as I mentioned before, we can also change our length and capacity. How are we going to do this? Well, I can say B1 is equal to B1, but I'm going to reslice it from 0 to 6. And then let's print this out and see what this looks like. Do you think it's going to change? Do you think this is going to throw an error? No, it's not. Now we're going to get a new slice into the same underlying array. And because the endpoint that I'm grabbing it to is still within the capacity of the array, it allowed me to expand my slice out even further. It's just a very convenient way of working with arrays. Okay. All right, so we have a couple more things to talk about here before we're done. There's a few more pieces, so this is turning into a pretty long video, but this is all very important stuff for being able to work with arrays very efficiently within Go. So the next thing we want to do is look at what is called the zero value. Okay, so we've looked at zero values of other types, but what is an empty integer slice? What does this look like? Okay. Now, if we do a format.println, I want to print out empty itself. I want you to see what that looks like. And then I want to see what the length of empty is. And I want to see what the capacity of empty is. And then, just for giggles, let's do a comparison check. Is empty equal to nil, which is the null value within Go? Let's see what this says. If we run through this, you'll see that, let's see, did we save that? Nope, I didn't save it. I forgot to save it before I ran it. Okay, so let's run it now. There we go. Now here's this. So we're going to get an empty array. Okay, empty has nothing in it. The length is 0 and the capacity is 0. And empty is equal to nil. So an empty array is null. It's empty. There's nothing in it. Okay, so that's the zero value of a slice. So we can see what it looks like. Okay. We can also create an array and a slice at exactly the same time. So let's create that right now. So we're going to say C:= equals, and we're going to create a slice. We're not going to give it a size. We're going to create a new slice, and we're going to create it using a literal. So I'm going to say 1, 3, 5, 7, 9. Okay. And then if I do a format.println on C, the length of C, and the capacity of C, you'll get to see what this looks like after it gets created. Okay, and so you can now see 1, 3, 5, 7, 9 is C now, and you can see that it has both a length and a capacity that are the same because it created the underlying array structure for us at the same time as creating the slice view into it. But we can do this with a lot more types other than integers, strings, things like that. Let's do it by dynamically creating a struct right now. Okay? So I'm going to create a new slice into a struct, and I'm going to declare the struct as part of this declaration. So I'm going to say x is an integer and y is an integer, and there we go. Now I can use the same literal syntax where I open it up after the struct declaration, and then I can pass in, I don't have to name the struct, it's a generic structure, and I can pass in the value 0, 0, and then I use a comma here to say that we're going to pass in multiple values, and then 0, 1, comma, 1, 1, comma, and 1, 0. So there we go. And then you have to do a comma at the end to say that new line. Okay? Now if I print this out and see what's inside of D, you'll see that now I have a slice created with structures inside of the slice, and I can see all 4 of them. This will also have a length and capacity of 4 since I'm creating it dynamically in line right here. Now this is great. This allows us to create these things dynamically on the fly. We can create them using literals. But what if we want to make an empty slice automatically with the array under the hood, but we don't want to use a literal? We want to just create an empty thing for us to store things into. But we also want to use it as a slice, not just as an array. Well, we can do that using a built-in function called make. So I'm going to create a new slice here. And I'm going to use make to make it. And we're going to use make for a lot of different things, but we can use it to create slices. Okay. And I'm going to create an int, so I'm telling it what I want to make. So in this case, I want to make an integer slice, and I want to give it the size of the thing that I want to make. So in this case, 5. Okay. Now if I println the underlying capacity of the array that got created as part of that command, you'll be able to see that it is size 5, exactly as we expect it to. And then I can modify this. I can say, nope, I want to grab only from index 1 to the end. And then I can do fmt.println the capacity of m. Will this change? What do you think? Let's run it and see. Yes, it does. That's because by using make, we have changed the way that the underlying structure works, and now we're dynamically resizing it because we don't need anything there. So we've changed the capacity down to 4 by slicing off the first, by cutting that first item off. And now we have a new slice that starts at 1 and goes from there. And we've popped that other object off the front, and it doesn't exist anymore. Okay. Now there's some other ways that we can work with this. Because we're working with slices, we have the ability to make, as I said, but we can also add stuff to the end of it. So let's say I want to put a bunch of items into m. What I can do is I can say m is equal to append. This is a function that will allow us to add objects or add items onto the slice, and they will get automatically resized. If I'm adding more things than there is capacity for, it will automatically resize the array for me under the hood to accommodate all of the items that I've added into it. Okay, so I'm going to pass in m, and then I'm going to pass in 1, 2, 3, 4, 5. So we already know the capacity of m right now is only 4 objects, but I'm passing 5 into append. So when I print this out, I'm going to print out m, I'm going to print out the length of m, and I'm going to print out the capacity of m. And you'll see that now everything is back to what it was. Right? So but I've added on to the end. So because I have 0 values here, I've added on to the end of those. Those were all there, the 4 objects there. I have 9 objects represented in there, but now my capacity is 10. So I have 10 total spaces in here that I can use, but I've only got 9 actually being used right now. So this is the way for us to append things onto the end of the existing array. We can see that we're still referencing from 1, but because it was 0 value, it's like the capacity was ignored above here. But once we actually start putting real data into this, we can see that we have the original capacity of 5 that we created plus 5 more objects. That's what we have to work with here. Okay. So, what else can we do with slices? There's only one more thing I really want to show you, and I can use a special for syntax to iterate over the slice and print out everything that's inside of it. Okay, so I can do for I, comma v, and I'm going to say I, comma v is equal to range. So this is a special keyword inside of Go of m. So I'm going to run the range of the m slice, and I will get out 2 values from this. I will get an index and the value itself stored at that index. So I can just print this out, and you'll see what's inside of I and v. So if I run this, it'll print those on each line, and you'll see at slot 0 is a 0, slot 1 is a 0, slot 2 is a 0, slot 3 is a 0, exactly as we expect to see here. But now you're getting the index and the value. But what if I don't want the index? What if I just want the value? Well, I can do that here too. I can say for underscore, comma, v, colon equals range of m. And I can do the same thing here. fmt dot print line, and I can print out just v. Now what this is doing here, because I'm doing an underscore, what this is telling Go is ignore this value. We don't care what this value is. It's still going to be sent to us, but we want to drop it, and we just don't want to see it. Okay, so now if I run this, you'll be able to see we get all the values printed out 1 line at a time. That's it. That was a very long lesson, but this is important stuff to be able to work inside of Go. You need to know how to create arrays, and you need to know how to create slices into those arrays and work with them. Hopefully you have a much better understanding of that now. If you have any questions, please feel free to drop them in the comments down below, and I will answer them as quickly as I can. Thank you all so much, and I look forward to seeing you in the next lesson.